Hi everybody, this is Lesson 10, Interpreting Graphs of Proportional Relationships. Your essential question is, what 2 points will always appear on the line representing two quantities that are proportional to each other? Okay, so for our first example, we're going to be talking about Grandma's Special Chocolate Chip Cookies. That makes 4 dozen cookies, calls for 3 cups of flour. Now, pay attention to 4 dozen. Later on, we're going to figure out how many cookies that really is. But as long as our label says dozen cookies, that's okay. We don't need to multiply by 12 the number of cookies in a dozen. So we can call it 4 dozen. It uses 3 cups of flour. So let's go ahead and complete the chart. What do you think is the x and which one is the y? We're going to say that if we have the flour, then we can make a certain number of cookies. Okay, so the flour is going to be our x and the cookies are going to be our y. So now where do 4 and 3 go? 4 dozen cookies needs 3 cups of flour. So let's go ahead and actually write in that flour is cups. We have to know that it's cups, not tablespoons or pints or something else. Okay, go ahead and fill in some more here. Pause it and see if you can fill in some other points of flour and dozens of cookies. Okay, so what I did was I doubled 3 and I doubled 4, and then I tripled 3 and I tripled 4, and then I quadrupled or multiplied by 4 and multiplied by 4. So that's how you know it's going to be proportional. If you determine the unit rate, then we know that it's going to be proportional. The number of cookies is proportional to the amount of flour because there is a constant of proportionality. Now, when you see this 1.3 repeating, don't worry because we're actually going to do this here, y over x. So y over x would be 4/3 or 8 over 6 or 12 over 9. But each one of those things equals 1.3 repeating or 1 1/3. So 1.3 repeating, or as a mixed number, 1 1/3. That one makes sense with cooking because if you are cooking, you can make 1 1/3 dozens for each cup of flour. Okay, so what does that mean in context of the problem? When you see that in context of the problem, that's saying for this problem. What does 1 1/3 or 1.3 repeating mean for this problem? Okay, so 4/3 means I can make 1 1/3 dozen cookies per cup of flour. Remember, we did the dozens of cookies divided by the cups of flour. That's why it's dozens of cookies per cup of flour. Okay, now don't get confused. Those are all the same number. 4/3 is the same as 1 1/3 is the same as 1.3 repeating. So don't say, well, you said it was 1 1/3 or you said it was 4/3. They are all the same number. So that's part of your number sense, is knowing that those are all the same thing. Okay, let's go ahead and graph it. The x we said was going to be flour, cups of flour. And I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 because look, it goes up to 12. So I have enough room for those. Okay, we know that's the x. And then on our y, it's going to be dozens of cookies. Now that one, we can also go up by 1. You could go up by another number if you wanted. Our last point isn't going to fit on there, but that's okay. You're going to see what happens here. So let's go ahead and graph. Let's go ahead and graph. If I have 3 cups of flour, I can make 4 dozen cookies. That was the one that was given to us. Keep going and graph those points from our table. So take these points and graph them here. Pause it, and then when you unpause, see if you got it right. 6 to 8, 9 to 12. Now, 12 to 16 isn't on there, but you know, we can kind of guess it would be right up there, right? Because if I connected a straight line, sorry, that's not totally straight. I just drew that freehand. But you can see that it's going to go up where 12, and then I don't know where 16 would be, 13, 14, 15, 16, if it had kept going. Okay, also pay attention to the fact that it's a straight line through the origin. I'm going to go ahead and make a better line because I think that's going to be confusing. So let me actually do a smart line here. So I'm going to pull up a line for you and you can see it a little bit better. Okay, so it looks like the line goes like that. And then if it would keep going, like I said, somewhere up there, it's hard for us to tell because there is no 16 dozen cookies, but it's going to be, it's going to be somewhere up there. Okay, it'll pass through the line. Okay, so now let's talk about, are they proportional? It goes through the origin and it's a straight line. Again, we could always do the y divided by the x, and that works too. If it's a straight line through the origin, then y divided by x will also be the same number every time. Okay, for our equation, we first want to write y equals kx. I've been telling you in class it is that simple, y equals kx. Then you want to replace k with the unit rate. And we know that unit rate is 4/3. So y equals 4/3 x. I like using 4/3 because it's much easier when it comes to actually multiplying by 4/3. Okay, and then it says to replace the x with y, the x and y with dozen and cups. So you can, since we know the y is the dozens, that would be D, and we know that the x is the cups, so that would be C. You can do that, but this is really what I'm looking for. If you can be good, if you are a pro at that, you're going to be great. Okay, for example 2. Now we're talking about sugar to cups of cookies. Now there are points already on here, so let's go with something that we know. So I can see that it goes through the origin, so that's 0, 0. That's the first one. The second one, it looks like it's 2, 3. The third point here, it looks like it goes through 4, 6. This one, so see where I'm coming from below here, in between 5 and 10. So I've got 8 for my x, that's right here, and I've got 12 right here. Okay, and then I'm going to change colors so we can kind of pay attention to this next one. It's got 12 for the x, then it looks like 18 for the y. And I said that the other day in class, y is always written x first, y second. And then our last point is going to be 15, or sorry, gotta be careful going down here. It's the next one, 16, 24. Okay, let's go ahead and record those in there. You can just draw that real quick off to the side. You just need a column for the x, a column for the y. So what do these pairs represent? What do they represent? The first number is the cups of sugar, and the second number is the dozens of cookies. So any one of these points that we wrote in here. 4 is the cups of sugar, 6 is the dozens of cookies. So what if she has 1 cup of sugar? How many dozens of cookies can she make? Well, that's really just our unit rate. So pause this, take any of these and divide the y by the x. Remember how we talked about doing y over x to find the unit rate? Go ahead and do that and see what you get. Okay, hopefully you got 1.5. You don't have to write all this down. I just want to make sure that you got 1.5 when you divide it. So you could have done 6 divided by 4, 3 divided by 2. You could have done 24 divided by 16. No matter what you get, it would be 1.5 or 1.5. And that point is right here. Okay, so where x is 1, y is 1.5. So even though it doesn't cross neatly and nicely like the rest of these, it's because that y is 1.5. It's kind of hard to tell, but that point is still there. Okay, all points are still there, even if they're not whole numbers. That's the whole numbers are where it passes nicely on the graph lines. Okay, so that means 1 cup of sugar would make 1.5 dozen cookies. So is it proportional? Hopefully you can tell that it is proportional. The unit rate is 1.5. So that's what we just said right here. You can write it in. Okay, how much can she make if she has no sugar? Those would be gross cookies. She cannot make any. No sugar, no cookies. Can you graph this on the coordinate plane above? Absolutely. No sugar, no cookies. That's the origin. That's what we've been talking about. We call that point the origin. Okay, so for every line that we have, if it's proportional, you'll see 0, 0. There will also be the unit rate. Even though when there was 1 cup of sugar, it wasn't a whole number for the dozens of cookies, but it still exists on there. There's always the number 1, whether it's right, right here on the line, or even if it goes up by 2 or 4, it's still on there. Okay, so when x is 1 is still going to be a point, whether it's a nice neat point easy to see, or whether it's a fraction or decimal that's kind of, not exactly on a line. Okay, I'm actually going to skip this one. I'm going to skip exercise 1. If you are up for a challenge, I want you to try it. But the one I want to do with you right now is actually exercise 2. So you can actually turn to page 41, and we are going to do this together. Your friend uses the equation C equals 50p to find the total cost C for the number of people P entering a local amusement park. Now, is $50, is that realistic for a local amusement park? If you've been to an amusement park, you know that those are actually pretty expensive to get into. So what this equation is telling us is it's saying that the total cost is going to be 50 times the number of people. So maybe you're going with a group of friends. I've had to buy large amounts of amusement park tickets when I was a camp counselor for all the kids at the camp. Maybe you're going with your family. So whatever it is, you're figuring out how many people and multiplying it by 50. So to make our table, we've done this before. You guys are definitely pros at this. So C is the cost and P is the number of people. Which one do you think is independent? Do the people determine the cost, or does the cost determine the people? It's true that if you had $200, then you could say, well, I can figure out how many people I bring, but the independent variable is the people. When you say I would like to buy 4 tickets, that's when they say, okay, it will cost this much. So the people determine the cost. So we can call that X, and we can call this one Y. So we know that one person costs $50 because that's our unit rate. Go ahead and figure out what 2, 3, and 4 people would cost. Pause it and fill that in. Okay, hopefully you got $100 for 2 people, $150 for 3 people, and $200 for 4 people. So is that proportional? Absolutely. Yes, because the unit rate is 50, which is the constant multiple. Show that proof in the table. You've heard me say that a lot. Okay, this is times 50, times 50. I'm always times 50, times 50. Some kids have been telling me, well, wait a second, what if nobody goes? What if nobody goes? Well, then we didn't pay anything. And the cool thing here is that times 50 actually works there because 0 people times $50 is 0. So that constant multiple that we proved here, it actually works. That same number will work there. So that's just something for you to see why it's proportional when it goes through the origin 0, 0. Okay, so 50, which is the cost, let's say in dollars. It's not 50 cents. It's the cost in dollars per ticket. Okay, now for the graph, I want you to pause it and try it on your own. Make sure that when you put your labels on here that your labels make sense. Okay, we already talked about the tickets being the X. For the people, same thing, number of people, number of tickets. And then the cost is the Y. So keep that in mind. Pause it and try this graph on your own. It's in your workbook. Okay, if you kind of want to space it out a little more, maybe you try to squish in the numbers, your line might look steeper, but that's okay because it still passes through the origin and it's still a straight line. So if yours looks different than mine, that doesn't mean it's wrong. As long as you have one person as $50, two people as 100, your line might be looking more here or here. And like I said, that's fine as long as your numbers match up. It's still correct. One person, two people, three people, and it would keep going. So you could have 5 people, you could have 6 people, however many it comes by. Okay, so the point that has to be on here, I think we talked about this already. You have to put in 0, 0. You have to put in 0, 0. Okay, no people, no cost. And then you really want to make sure that you have the unit rate. One person, $50. Okay, what does 5, 250 represent? Would it be on the graph? That's what I was saying here. If you extend this line and you keep these going, 200, 250, and you kept 5, it would go straight through where we would have 5 people being $250. Okay, so if I were to graph that, I just kind of put those on there real quick, so I didn't count carefully. Okay, but that would be on that line. See if that line kept going, it would go through there. Again, I didn't count carefully, so that might be off by a tiny bit, but you can see that it's the same pattern. Okay, so what does that represent? It means that 5 people would cost $250. Okay, and that is a wrap on lesson number 10.